All right, now let's look at this third part of this problem. We know that if this die is really unfair with a 2-to-1 ratio favoring the bigger numbers, then after a long run, we should be able to use experiments to verify this. So what it means is that Bayes updating should somehow make it possible for Dr. Jiang to believe eventually with almost a probability 1 that this die is unfair with this 2-to-1 ratio of getting bigger numbers. So we're going to try to see if that's possible. We have seen that if this die is rolled 3 times and every time favors, every time results in a number, a bigger number, then the probability of believing in this unfairness increased from 0.2 to 0.39. Okay, so now let's try to see what's going to happen if we roll many times. Okay, so assuming it's fair, and we're going to try to see what is the probability we're going to get 2n of bigger numbers and 1n of small numbers. And this involves a little bit combinatorics, but we can just write down the results without much explanation. Okay. All right. So we're going to write down the probability. So what is the probability over here? Suppose it's fair, and what's going to be the probability? Given fair, let's say A, and what's the probability of B? And B event over here, that means 2n larger numbers. We have larger numbers. That's 4, 5, and 6. So we just this event over here. And with n over here, smaller numbers. N times we have 1, 2, 3, this kind. So what is the probability? We know if it's fair, then it's 1/2 favors 4, 5, 6, or 1, 2, 3. But here there is a catch. We cannot just use 1/2 to the power 2n and multiply it by 1/2 to the n. That's still true, but we have to repeat this one for we use so-called a combination number of C3nn, because there are different cases we can get 2n larger numbers and 1n smaller numbers. So this is the probability, and this one over here is the probability, if it's fair, how to get 2n larger numbers and 1n smaller numbers. Okay, and if it's unfair, it's similar. So we have, if it's unfair, we still can have this kind of event if it's unfair, and the probability becomes 2/3 bigger numbers 2n times and 1/3 smaller numbers. Okay, and we have the same number of different ways to get 2n bigger numbers and 1n small numbers. Okay, so that's what we have over here, and that's the probability of given unfair, and this is what we have. Okay. So now what do we want to do? We want to find, assuming that we now have 2n times of bigger numbers and 1n smaller numbers, what we can do about the how should we believe that this is unfair? And then again, we look at these branches over here, these 2 branches over here. Okay? So the probability, given B has happened, what is the probability that this is unfair? That means we have over here AC. We will look at the product, the sum of products of 2 branches. So what we have again is still 0.8 times first branch. We're going to put a C in the front, but that you will see it's going to be canceled. Okay, and then we have 1/2 to the 2n and 1/2 to the n. So that's from first branch. And then look at second branch, it's 0.2 and multiplied by the unfair. If 1 is unfair, so we have 2/3 2n and 1/3. We forgot this constant over here, but it's going to be cancelled. Okay. And on the top, we want to find the probability, conditional probability, if B has happened, what the probability is unfair. And we put this branch on top. Okay. So you will see this is on the top. Okay. And C, 3n, n, these combination numbers. And we can cancel these combination numbers because they are going to be the same. Okay. So let's move on a little bit and to see what we have. And then we're going to finish the computation, in fact. So what we have over here now is the following. We have 0.2, and we have 2 to the 2n, and over 3 to the 3n. That's in the numerator. And in the denominator, we have 0.8, and we have 1 over 2 to the 3n over here, and plus 0.2. And here we're going to have 2 to the n, 2n again, and 3 to the 3n. Okay. So try to simplify a little bit, and that's what we're going to have. We're going to have 0.2 on the top, okay? And then we will have 0.8 over here, and then we're going to have 3 to the 3n over 2 to the 3n and 2 to the 2n over here, and then plus 0.2. So that's what we have. Now let's try to compute what 3 to the 3n is. This is really 27 to the n, okay, because it's 3 to the third. And then at the bottom over here, 2 to the 3n times 2 to the 2n, that's going to be 8 to the n times 4 to the n. So it's 32 to the n. And then we will see this one over here is 0.2 over 0.8, and we have 27 over 32 to the n, and plus 0.2. So that's what we have. And we see this number over here goes to 0 when n goes to large, right? So this probability goes to 0.2 over 0.2, and it's going to be 1. So that's what we have, that when n becomes large, actually the probability is approaching 1, that we should believe that this die is unfair with 2-to-1 ratio, favoring bigger numbers. Now let's try the last one over here. Let's assume that at the very beginning that Dr. Chen doesn't believe this insider at all, that the initial belief that this die is unfair is 0. And he was 100% sure this die was fair. Now we're going to do the same experiment. Roll the die 3n times, and with 2-to-1 ratio, 2n times we have bigger numbers, and 1n times we have smaller numbers. Let's try to see if his belief is also modified with these experiments. So what we have now to begin with is that with probability 1, he believes it's fair. And with probability 0, he believes it's unfair. Okay? And if it's fair, we still have this same structure over here. This is going to be, if it's fair, then we're going to have 1/2 to the 2n and 1/2 to the 2n to the n, and multiply by c on 3n. So this is the same thing. Unfair is still the same thing, 2/3 to n and 1/3 to the n, and c 3n and n. Okay. And we have exactly the same formula. So given that b has happened, that means we have this number of bigger numbers and 2n bigger numbers and n, 1n small numbers. What's going to be the probability that he is going to believe this die is unfair? And then if we look at it, we see that this branch over here again, so 1 times this, and this branch is 0 times this. So we will see that in the denominator we have 1 times 1/2 to the 2n and 1/2 to the n, and c 3n n, but this part is going to be 0. And what we have on the top is also 0, because this is 0 times whatever we have over here is going to be just 0 over here. So the probability is 0 over some number over here isn't 0. That's going to be a non-zero number. In fact, it's going to be C3n C3n times 1 over 2 to the 3n. But it's a non-zero number. It's going to be equal to 0. So what it means is that if his initial belief in the fairness of this die is 100%, then this Bayes updating is not going to change his belief. There is no way. It doesn't matter. He's going to ignore all the evidences.